Welcome to the beginning of Dynamic Systems and Control. Dynamic Systems and Control is primarily a three-part class wherein which we teach the modeling of a particular system. We will take a suspension, for example. A suspension has multiple components to it: a damper, a spring, and some mass that's attached to that suspension. Remember, the wheel is also part of the suspension system. The wheel has a mass as well as all the other components. Once we've modeled the system, we may want to understand its dynamics. Given a particular impulse, let's say it goes over a bump, what kind of forces will the user feel? It's very important to gain these kinds of insights so that we know whether or not the system that we've actually designed would hold up to a particular use case that we have. And thirdly, maybe we want to design an active suspension where an actuator is attached to the model and the desired output or the desired outcome is achieved. For example, we have some hydraulic fluid that has metallic particles in it and is controlled with an electromagnet. This changes the dampening coefficient and you have the desired output. So, in this video, we will be talking about a single sort of component. There are four different kinds of components. The first component is translational, the second component is electrical, the third component is rotational, and the fourth component is hydraulic. For the first example, translational, you could take a car suspension to be an example. An electrical component maybe an RC circuit, a resistor capacitor circuit, maybe even a light bulb circuit. For rotational, you can think of a turbine. As the blades spin, there's energy that's stored within the shaft, energy that's being lost from the bearings, and energy that's also being effectively stored within flywheels. Hydraulic examples may include systems that run with liquids in them, such as water tanks on different levels, tubing, and other sorts of systems with liquid in them. But in this video, we'll be focusing on translational components. There are three major translational components that are one-port examples. We will be starting off with the basic one-port examples. There are other components with two, maybe even three ports, but in this tutorial, we will only cover one-port translational components. One-port translational components include masses, springs, and dampers. These all have electrical equivalencies, which we will be using to effectively model circuits based on these models. So a mass can be compared to an inductor, a spring can be compared to a capacitor, and a damper can be compared to a resistor. If you don't know what a damper is, imagine that we have a tube, a piston on either end, and another encapsulating tube with maybe oil in it, a thick viscous fluid. It resists motion on either direction. A spring stores energy. When it's translated off its baseline, the displacement, we'll call it x, is effectively how much energy is stored in that spring. Now we'll take this to be an ideal spring in most situations if the deflection is small enough. And the mass, a ball bearing, when it's moving, basically the object has momentum associated with it. And next we will be going over the ideas of flow and effort. Thanks again and subscribe if you want more content on mechanical engineering simplified.